All right. So the schedule today is we're going to do a review for our first test, and also there will be a quiz number two, which is sort of a vocabulary quiz like the first one, and it will cover the last three chapters, I believe, chapters three, four, and five. Very basic definitions. So if you've been following along and you have your books with you, you shouldn't have any issues with the quiz. The test right now is scheduled for Monday, and will cover the first five chapters. Now, obviously, there's certain sections that are covered in certain sections in each chapter that are not covered. So let me review that with you now, so that you know what we've covered so far. Chapter one, I think, was a short chapter, and we covered everything in chapter one, mostly definitions. Chapter two, also mostly definitions. We covered sections 1, 2, and I think we covered the first four sections of chapter 2. Now, section 5 of chapter 2 we did not cover, so that's not part of the course. So basically, for chapter 2, sections 1 through 4. Chapter 3, we covered section 1. Hold on 1 second, people are still coming in. We covered section 1, section 2, section 3, and we did cover now section 4, 3.4. I had mentioned that the PowerPoint did not cover the scatter plots. So I would say just don't worry about section 3.4. I'm not going to actually ask you to create a scatter plot. You should know how to do it with your calculator in case you want to look at whether the data looks linear or not linear. But I won't ask you to create one, so don't worry about the scatter plot so much. So section 3.4, not so much. You don't need to pay attention to that so much. 3.5, don't pay attention to it. And chapter 4, sections 1, 2, 3, and 4. And then again, section 5, don't pay attention to that one. Then chapter 5, I will review today what you need to know. It's the first two sections, but even in those two sections, there's especially 5.2. There's only a little bit that you need to know. A lot of it in here with the formulas and looking at computer software output and that sort of thing. We will not be covering any of that. It's only certain items that we'll be covering in chapter 5. And as I had mentioned last time, it's mostly on the level of high school, what you learned in high school in this subject. So it's relatively simple. And so I'll make it clear what you need to know. And that is what's covered in the test. Now, the test will be what I've been doing the last few semesters. I've been creating, at least the last 2 semesters during the pandemic, I've been creating 22 question multiple choice test, 5 points each, so for a total of 110 points. There's extra credit that's thrown in there. And don't worry about how it's calculated in Canvas. I do an adjustment to each person's grade. So whatever score you get, I multiply it by 1.1. I do that by hand, and therefore whatever score shows up will turn out to be the correct percentage in Canvas. So don't worry about that. The math is taken care of. I'll take care of it. It works out fine. And I know that some people, other professors who've worked with Canvas who are not mathematically inclined, don't know how to do what I do, but I think probably all the statistics professors know how to do it. So don't worry, what you'll see ultimately in Canvas is your correct grade, right? The quizzes and the homework, they're just graded based on points, and there's no extra credit with those. But for the tests there are, and also for the final exam, there's some extra credit thrown into that also. But don't worry about all of that right now. I think your concern should be on test number 1. Now, I also put homework number 2 out. And one thing I do want to do before I do the review is I want to show you a little bit about the ebook. If you're using the ebook as opposed to the textbook. Now, the ebook has everything that the textbook has. It's the same, everything's the same. It's just, you have to get used to the way you maneuver around the ebook to get to things. So what I'm going to do is I'm going to, just give me a second here, I'm going to open up Cengage and open up that ebook. And once it's open, I will share it with you. Just give me a minute. All right. So all of you should be able to see this screen here, hopefully. It's Cengage's ebook for this course. Now, to get to anything here, you just click the chapter. For example, let's say we're in chapter 5. So I click chapter 5, and then you can read the various sections that are in here. Let me just move things out of the way. All right, so you can click on any of these sections. Notice at the end of each section are the exercises. So when I refer to the exercises, now, as opposed to the first homework where I gave page numbers, this time I referred to the section number. All right, so that's for those of you using ebook, you just go to that section's exercises and you'll find the homework problems there. All right. But if, let's say, you wanted to get to the exercises in 5.2, you would just click that, and then it would give you the exercises that are shown in the book. Now, one thing I wanted to show to you that's important, and maybe you've already figured it out, hopefully you have, is that when they give charts in the ebook, what they do is they sort of cut it off at the bottom here. Do you see this sort of like, it looks like it's a torn page, this little thing here? And it has a plus next to the table, and it says enlarge the table. So if you hit the plus sign, you will see, and then scroll over. So you scroll over, and you'll see the whole table that's listed here. All right. So this is the entire table. So please don't use just what you see where it shows the torn page on the screen. You need to click the plus sign and get to the actual full table, which will match what's in the textbook, the paper textbook. All right. So I hope all of you knew this already, figured it out. But if you had an issue with the homework because you were getting the wrong answer, and it's because maybe you did not know this, you were looking at the only a portion of the table of the data, then send me an email and I will give you another attempt at doing that homework problem. Okay, because this is something that was new. Cengage is new for this textbook. This textbook was originally published by Wiley, and it's only this newest edition is now published by Cengage. So Cengage does some things that are different than Wiley, and maybe this is one of those things. So I did want to bring it to your attention for those of you who are using the ebook, so that you don't make the mistake of thinking what you're seeing on the screen the entire table. You basically have to hit that plus sign. Once again, it's this plus sign right here next to the table, whatever table you're looking at, because I think all the tables are like that if they're relatively long. See, here's another one like that. There's another one where you have to hit the plus sign and you get to, and that's table. All right, and again, you scroll over till you can see it all. There's the table there. So again, wanted to bring that to your attention. And if in the first homework, not the second homework, in the first homework, you had issues with being able to see the data ebook, then now that you are able to, you know how to do it, do send me an email. I will extend the homework for you so you can, or give you another chance to complete it correctly. Any questions about the ebook? All right, how to get to the exercises, also reading too. Obviously you'll be reading the different sections. Now, if you want to get out of where you've been, you just hit the text sign there, and then you're back to the main screen again. Once again, if you want to, let's go to chapter 3 here, and if you want to read, now notice here it gives you the goes right to the exercises, which is kind of weird that it does that. But if you want to get out of this kind of loop here, you sort of hit the arrow key and then go back to the, again, go back to the main screen, and then you can pick the correct section that you want to start in. All right, so if you want to read about pie charts, you just click that, and then it takes you right to the pie chart section. All right. So you just have to learn how to maneuver. I wasn't trained on this either. I just figured it out on my own. And I think that's what you have to do. But if you have any issues understanding any of this, just call Cengage customer service, and hopefully they'll respond in a reasonable amount of time, and they'll explain any issues you're having with the ebook. All right. Any questions? All right. What I'm going to do now is actually use the ebook here and go through some of the topics. And also I want to take a quick look at the homework and give you some hints about what you should be doing, because I think some of you, you're going through the homework pretty quickly, your scores aren't that high, and maybe you're not going back and looking at what you need to look at to do the homework properly. Let's go through what you need to know for the course, and then I'll give you some hints about the homework, and that should do it for today. Oh, excuse me, and not do it for today, but I'm going to stop around 1:20. At 1:20, we'll take quiz number 2. All right, because I have that all already set up for you. Okay, and then remember that during quizzes and tests, unless you have a broken video, you have to have the video on, and you do have to let me know each and every time that your video is broken. Please fix it though before the end of the semester, because I can tell you for sure that you will not be able to take the final without me seeing you. All right, the final exam, I have to see every single person. So you have to have a working computer with a working video. All right, and that means if yours doesn't work, you have to find somebody else's that does. And I really should require that for my tests also, but I'll give you a little bit of a break if you are having that issue and it's taking time to get it fixed. We're getting a new video unit or new camera, but you have to have it fixed by the final exam. It has to be fixed. Okay, so I'm just letting you know that ahead of time. All right, let's go to chapter 1. And again, in chapter 1, it's just an introductory chapter with some definitions in it. What I want you to pay attention to more than anything in chapter 1 is the types of data. I mean, you have to know everything in here. I'm not saying you shouldn't. I'm just pointing out some things that it would put a little more emphasis on. the types of data. All right. Here they, of course, talk about a definition of what a variable is and what data is. You should, of course, know what univariate means. It means one variable. Bivariate means two variables, and multivariate means more than two variables. You should know the difference between categorical and numerical data. That's very important. So that's something that it's very important to know for the first test and certainly for the final exam also. All right, we give you plenty of examples in here of the difference between the two. All right, so shouldn't be any issues with that sort of definition. There's two types of numerical data. Well, numerical data can be classified in different ways, but on this page, they mentioned the two types that you need to know for this test and for the final exam. The difference between discrete and continuous, right? Because we're going to be using both discrete and continuous data throughout the course, and you have to know the difference. So just definitely know what the definitions are. They're right here, all right? And they gave you, again, plenty of examples that will help you distinguish between the two. All right, let me just go back for a second. Let me see if there's anything else in this section you need to know besides discrete and continuous. All right. Frequency distributions and bar charts. Now, bar charts are used strictly for categorical data. Histograms are used for numerical data. They look somewhat alike because they both use rectangles, bar charts and histograms. But they look, and they also use frequencies and relative frequencies. The difference is that the data, the actual data, is different. The bar chart's categorical data. So for counting the number of different car types in a car lot, you count the number that are Toyotas, and the number that are Hondas, like that. And then we display it. We'll display it as a bar chart, where along the x-axis we'll have the names of the different types of cars, Honda, Toyota, and then the height of the rectangles will be the frequency, the number of cars that are on the car lot, and that for that type of brand of car. A histogram, the data that's along the x-axis is numeric. All right, it's numerical, it's quantitative. So that's the difference between the two. All right, describes what frequency is. It's just a count. Relative frequency is a percentage or a proportion, depending whether you express it as a decimal or as a percentage. Here's the simple formula for relative frequency. It's just the frequency divided by the total number of observations in the data set. Okay? Very straightforward. You should all know how to calculate a relative frequency if you're given a frequency. We give, again, examples of frequency distribution table for categories. Here are three categories. Here are the counts. Here's the total number of observations, 806, and then here are the relative frequencies. You take a frequency, divide by the total number of observations to get these frequencies. Notice that the totals for the frequencies always add up to the total number of observations in the data set. The total of the relative frequencies always add up to 1. If it's 0.999 or 1.001, it's a rounding error. That's the only reason for that. Okay. So again, bar charts are used for categorical data for counting. There is a bar chart. Okay, and the heights of these bars are the frequencies or the counts. Okay. Then they have other types of things here, other types of displays. A dot plot is used strictly for numerical data. This is what a dot plot looks like. So you just a number line, and along the number line are different values for the numerical variable that we're looking at. And above each of these is a dot, which represents one value in the data set for that number. If there are two dots, it means there's two numbers in the data set. Like there's two dots above 50, that means there's two 50s in the data set. What's the most frequent one in the data set? It's 100, right? Because there's many dots. You just have to count the number of dots. It tells you the frequency for the value 100. This is one way of displaying numeric or quantitative data, is through a dot plot. And then, of course, I had mentioned also the histogram. All right. Once again, the ebook, as opposed to the textbook, only shows you a portion of the actual table that's in the textbook. So you have to hit the plus sign once again to see the entire table. All right, so that's very important to know that. Here are some dot plots where you can make comparisons. And what are you comparing? You're comparing where the center of the distribution of dots are. You're looking how variable they are. I mean, the first one here looks like it's tailing off to the left, and it's more variable, right? Because you see a dot all the way down here, and you see dots all the way up here. These dots on the bottom dot plot have less variability. The dots are closer to each other, and it's more symmetric, right? More symmetric. So the shape of the distribution you can also see from the dot plot. Okay. And then we have our exercises. That's chapter 1. Chapter 1 goes pretty fast, and there's definitions in there. There's some plotting that's in there. You just have to know the basics, that's all. All right, go to chapter 2. Chapter 2 has to do with collecting data. And what do you have to know for chapter 2? Well, and they give some early examples. You have to know the difference between observational studies and experiments. So read through those definitions. It's right here. All right, that's important. Drawing conclusions from statistical studies. Here they're asking whether you can generalize your conclusions from the study to the population. Well, that has to do with whether you collected a random sample from the population. Notice if you collect a random sample, the answer is yes. Okay. For an observational study, it's only yes for an experiment if the people who were selected for the study were selected randomly for the study. All right. So experiments are not necessarily, even though most people would apply the results to the population, they don't necessarily apply to the population if the participants were not selected randomly from the population. So that's an important concept right there, the idea of when can you generalize the results to the whole population. Okay, so that's the first section. Now we'll go to section 2, sampling. All right. So what do we need to know about sampling? Well, what sampling is, of course, is you're getting a subset of the population. If you survey everyone in the population, that's called a census. You know that definition. You know about the different types of biases that can occur in sampling. Selection bias, measurement bias, and I think there was non-response bias. Yeah, there it is. You need to know these 3 definitions and look at the examples so that you can recognize them if you're being asked about bias. Talks about what random sampling in general is, all right? And it means that everyone in the population has an equal chance of being selected for the sample. That's in general. And then we have to know the different types of random sampling. The simple random sample means that the sample chosen using a method ensures that each different possible sample of the desired size has an equal chance of being chosen. That's a simple random sample, all right? And this would be the example where if you have 1,000 people and you're choosing 100 randomly from the population of 1,000, you just number everybody in the population from 1 to 1,000, and then you randomly select 100 numbers from 1 to 1,000, and those 100 numbers, whoever was assigned that number, gets to be in the sample. That's called simple random sample. It's very easy to understand. And notice that the size of the sample, n, small n, represents the number of people in the sample. So in the example I just gave you, the sample size was 100. Okay, so small n represents the sample size. By the way, if we wanted to represent the population size in the example I just gave, which is 1,000, we would use capital N for population size. All right. And then it gives you, again, ways of selecting a simple random sample. Some people use computers, some people use tables, but it's pretty much the same thing. Now, one thing you have to know are the two types of sampling down on this page here. Sampling with replacement and sampling without replacement. You need to know these definitions. And sampling with replacement, without replacement means that once you take someone out of the population and let's say you do a survey and you ask them the questions, they're permanently removed from the population, and then the next person selected would not be that person. So that person who was chosen initially could never be chosen again. However, sampling with replacement would mean that once you survey somebody, you put them back into the population, and there's a chance that you could select them again. Now, the question you might say is, why would you want to do sampling with replacement? It's because you want to keep the probabilities the same, that each person selected would have the same probability to be selected for the sample. However, if your sample size is small relative to the population size, then even if you do sampling without replacement, which is ordinarily what you do when you do surveys, you don't repeat giving a survey to the same person, the probabilities are not going to change very much when you remove that person from the population. Probabilities will stay about the same. All right? Just know those definitions and know the difference between those two types of sampling. Okay. And then it talks in this section here that it's a common misconception that if you have a relatively small sample, you cannot possibly generalize to the entire population. And they can try to convince you in this section, yes, you can. You can have a small sample, even if you have a population that's very large, you could have a sample size 50 or 100. And they show you that you can have the results are reasonably close to what the population looks like. So it's a fairly good representative of the population, even a small sample. All right. Now, besides simple random sampling, you have to know about stratified sampling. And that's when you break up the population into groups, and then you do simple random samples within each group. You have to know that the difference between that and cluster sampling, where you break the population into groups, and then you do simple random samples of the groups. Not all the groups are going to be represented in this final sample with cluster sampling, and then you just survey everybody within each selected group cluster. So you have to know the difference. And systematic sampling is where you pick some number randomly from 1 up to a certain type of number, like 50 or 200, and then every 50th or every 200th person after that will be selected in the sample. That's called systematic sampling. So you should make sure you understand that by just looking at the example in the book. And know that convenience sampling or voluntary sampling is not random sampling, and therefore we cannot generalize the results to the population. All right, and that's pretty much what you need to know about chapter 2, or random sampling. Right? Or that section, random sampling. Now, experimental design, what do you need to know? Just some basic definitions of experimental design. Okay. They give you some diagrams here. This is an example of what they call random assignment of experimental units to what? To treatments. Well, who are the experimental units? They're the participants in the study. All right, they're the people who are who are in the study. So random assignment means randomly assigning those people to different treatments. And this is a completely randomized design here. They're randomly designed. Now, there could be more than 2 treatments, but this is the simplest case here of 2 treatments. All right. And what is random assignment? What it does is it allows you to assume that the 2 groups are going to be relatively the same, except for what? Except for the variable that's changing, the explanatory variable that the researchers are changing, or the different treatments here. The differences in the treatments, the effects of that on the response variable, which could be some disease or something like that, whether the person gets the disease or not. You can conclude from random assignment that if there's any changes to the response variable, that the disease, it's due to the differences in the treatments, and it's not due to some other factors. Those other factors sometimes are called confounding factors. Randomization allows you to do what? Allows you to say cause and effect. If I make changes to the treatments, I'm going to create a cause, which is a change in the response variable. All right? And they give you different examples in the book. You just know in general what this type of design does. Okay. Okay, and then the next section, just a little bit, some more definitions for you to know. You have to know sometimes that besides a treatment group, they have what's called a control group, where they have a lack of the treatment. All right, it's there to make a comparison between, to see if the treatment is actually working or not. So control group, and sometimes the control groups use placebos. Placebo would be like would look like a drug, for example, and maybe taste like a drug, but it wouldn't have the active ingredients of a drug. You have to know what a placebo is. And then the idea of blinding, right? If single blind means that either the participants or the people administering the experiment do not know who's getting what treatment, one or the other. Double blind means both the participants and the people administering the treatments don't know who's getting what. All right, and why do they do that? To prevent what's called the placebo effect, which is mentioned in the book here. Experimental unit, you have to know the definition of that. All right, that's the participants getting the treatments in the study. All right, and then the idea of using volunteers means that you cannot generalize the results to the whole population. So that's chapter 2. And then chapter 3 are the graphical methods, and I'll just briefly mention what they are, and then I'm going to mention just briefly the other things that you need to know. All right, so chapter 3, because we're running a little bit behind here. So let me get to chapter 3 here. And what's in section 1, we have our bar charts, we have our pie charts, all for what? All for categorical data. So that's what you need to look at. Just know general that these charts are used for categorical data. And then in section 2, I just want to make sure that you know about these stem and leaf displays. I'm not going to ask you to create a stem and leaf. All right, they may look like this. All right, let me just see examples of stem and leaves. Here's one right here. Now, a stem and leaf means that there's a vertical line, and to the left is what are called the stems. They're usually the first or second digits of the numbers that are in the data set, and then the other numbers in the data set fall to the right, and they're called the leaves. Now, if I show you a stem and leaf, it'll be much simpler than this. Typically, I'll show you one where there's just one number, one or two numbers that are stems, and then it'll just be one single digit numbers to the right. And the way to read this one, for example, is you just combine the stem with the leaf. And for example, this one would be 4,438. The next number would be 4,179. Okay. So you should be able to read numbers off of a stem and leaf, because I may give you on your test a stem and leaf, a simple one, not one that's hard to read. This is a little harder to read, but I'll give you a simple one that it's easy to read. You should be able to take that data and enter it into your calculator as a list. All right. So you go into stat and enter it as a list, and then you can find things like the mean, standard deviation. You can find anything that's in one variable statistics on your calculator. You can find any of it once you've entered the values from a stem and leaf. All right, so that's one thing that I can do, is give you a stem and leaf and then ask you to quote unquote calculate certain things, but most likely the only thing you have to do is look it up. You have to enter the numbers into a list and then just look up the answers. That's pretty much what you'll be doing. Okay, and then they talk about repeated stems and things like that. I'll keep the stem and leaf pretty simple. All right, I'm not going to create a complicated one for you. And then the histograms. The histograms, I showed you in class how to create a histogram with your calculator. I will not ask you to create one and then ask you which of the following is the correct one. What I'll probably do is one of two things. I will give you a histogram and ask you questions about it, just like I did in the first homework. Or I can imply that you're going to create one using a calculator, and then I'll ask questions about the one you've created with your calculator. All right. So there is a section in your there is a video that I did on histograms. You should review that again. Make sure you review all the videos again. Obviously, you can skip through those things that you already know, and find the one on histograms and review how the steps of creating a histogram in case I ask you questions about a histogram without displaying it. And what I'm assuming is that you've created it with your calculator. Okay. So that's something that you should know how to do. So go back and figure that out. You should also know that each of the units that are on the bottom of the histogram here are going to be categories. That's not categories meaning categorical data, but they would be classes of the numeric data. So what you're counting is maybe the number of numbers, the values in your data set that are between two numbers, like between 1 and 5, between 6 and 10, things like that. All right. These histograms here are simply counting the number of values that represent each of these numbers. But many data sets don't have numbers that repeat. So what do? You create classes of numbers. And that is what I demonstrated in class when I created a histogram in class. And I think it was problem exercise 3.25 that I showed you in class and how to create that histogram. Okay, so that is this section here. You should be able to answer questions like for example, if you have a histogram that looks like this, and I ask you what percentage of the data is between that's less than 80 but greater than or equal to 50. In other words, between 50 but not including 80, you would add up the first three classes here. All right, the relative frequencies. It would be these three relative frequencies. It would be 0.08 plus 0.14 is 0.22 plus 0.2 is 0.42. So the answer is 42%. I asked questions like that in the first homework. You should be able to read a table and be able to answer questions about what percentage is between two values, or greater than some value, less than some value, by simply looking at the relative frequencies and coming up with your answers. Now, of course, if I asked the number of values but between 50 and 80, you would just add up these three numbers and come up with 21.
I have a question.
Yeah.
For the first homework, you didn't go over this like before that we did the homework, right?
Right. And the whole idea, that's right, because I wanted you to try it on your own to see if you could figure it out. I will do that if you've actually gone in here and read the textbook, you would see, because I can't cover everything in class. It's impossible. So I'm requesting that you read the textbook, and the homework is to test to see if you can figure it out on your own. Now, you can always send me an email and say, I'm stuck on this, give me a hint. All right?
Yeah.
But the homework doesn't make any sense to give to you if you know how to do something. If I explain exactly how to do it, what's the point of giving you the homework? It wouldn't actually be meaningful to you. This is something that you could do, try it on your own, see how you do. That's the way the homework should be. And I would never give you a homework problem where it's so difficult, there's no way that you could figure it out. That wouldn't be fair. But this you could do. You could figure this out. But I'm
Yeah,
showing you up front how it's done now. Okay.
yeah,
Good. And then they tell you about histograms for continuous data, and then you create these categories. Now, this section here, where it talks about intervals that are unequal in width, don't do these. All right, they're too complicated. I'm not going to go over that with you. I'm never going to test you on that. Final exam will never test you on that. So skip this section here. All right, and then later on they talk about cumulative frequencies, but what's also important in here are the definitions of unimodal, bimodal, and multimodal. Know these definitions. And also skewness, extremely important. Make sure you know the difference between symmetric and skewed, and know what we mean by right skewed, left skewed. Another word for right skewed, a phrase for right skewed is positively skewed. Another way of saying left skewed is negatively skewed. All right. So that is what you need to know for chapter 3 in this section here. All right. They give you the cumulative relative frequencies, which just means a running total. Please just go through those examples. And again, these are things that I think you can do on your own. And figuring out cumulative relative frequencies, you just keep adding. Like if I wanted to know what percentage of people weighed less than 10 pounds, well, it would be the 0 to 5 group plus the 5 to 10 group. The cumulative frequency, which is what I'm asking for, is 0.15 or 15%. Okay, so there we go. All right, so that's section 3.3. And then on the section 3.4, I mentioned that you can just skip that because in chapter 5, we're dealing with that. And then chapter 4, what I'll just very quickly tell you what you need to know in chapter 4. Back to chapter 4. Okay. For some reason, not letting me. So get out of here. Let me go here. There we go. So what was in these chapters? The mean in section 4.1, the mean, the median. Know how the mean relates to the median with reference to what? With reference to whether it's skewed left or skewed right. Skewed right, the mean is greater than the median. Skewed left, the mean is less than the median. You should know the reason behind it too. So go over that. If it's symmetric, the mean should be approximately equal to the median. In section 4.2, you should be able to know what a standard deviation is. Just in general, you don't need to know the formula perfectly, but you should know in general how the formula was created. You don't need to use it because if you have a data set, you just enter it into your calculator as a list, go to one variable statistics. And if it's a sample, if you scroll down in one variable statistics, it is the S. Whatever S is equal to, that's the standard deviation for a sample. What is the interquartile range? It is now you know the median is what? The median is the number in the middle. And the definition is that 50% of the data is less than that, 50% of the data is bigger than that. If you took the lower half of the data and found the median of that, that would be the lower quartile, or what's called Q1. And then if you took the upper half and found the median of that, that's called Q3, or the upper quartile or third quartile. The lower quartile, Q1, or the first quartile, means 25% of the data is less than that number, 75% is greater. And Q3, the upper quartile, means 75% of the data is less than that number, 25% is greater. And the value of knowing the 5-number summary, which is the next section, is that you can graph it using a box plot. You'll know, and what it does, the box plot, it breaks the data into 4 equal quarters. You should be able to know. between two numbers, whether it's 25% of the data, 50% of the data, or 75% of the data. In addition, and also you should be able to calculate, very important, outliers, right? You take the interquartile range, Q3 minus Q1, multiply it by 1.5. That tells you, gives you, and they tell you how to do this, and you add it to the upper quartile and subtract it from the lower quartile, and then any values that are bigger than that sum on the upper quartile is going to be your a moderate outlier, and then on the lower end would be the less than that value, that the subtraction number that you came up with will be the moderate outlier on the low side. And then they said if you took your interquartile range and multiplied by 3 and added and subtracted like they show in the textbook, you can determine extreme outliers. All right. So review that. I can't say it completely right now because we're running out of time. Also know about Chebyshev's rule, the empirical rule, and z-scores. Make sure you know all three of these. They will be tested in the test. All right. Percentiles, not too much on percentiles, but just know the general definition. If I say the 30th percentile, I mean 30% of the data is less than that. 70% of the data is greater than that. And then in chapter 5, the last thing. Now we're running a little bit behind, so I'll give you a couple extra minutes for the quiz. But I don't think you'll need it, but if anybody needs it, I'll let you have extra time. In chapter 5, it's very, very particular what I'm going to ask. The homework will go over it. And basically what I'm going to give you is is 2 variables. And I'm going to ask you, number 1, the correlation. Number 2, I'm going to ask you the equation. If one of the variables is going to be your x and the other variable is going to be your y, what's the equation? The linear equation. So it's going to be y is equal to mx plus b. That's what we learned in high school, but they use different letters in the textbook. But it's basically the slope times x plus the y-intercept. So you come up with the equation of best fit, the regression line equation, and then you can make a prediction based on that. That is, if I give you an x, you plug it into the equation, and you get your predicted y. That's pretty much it. That was what you learned, what people are learning in high school right now. And that's all that you need to know for chapter 5. And there's an example in the homework, the newest homework for that. All right. So anyway, that is it. And as far as the homework is concerned, I hopefully this homework will be pretty straightforward. Remember to review the sections that apply to the homework first before you attempt the homework. Don't just think that you know it and then get a low score, and I give you 3 attempts, so you should be able to correct yourself by going back and reviewing. So make sure you spend adequate time on your homework. All right.
What chapter is it on?
What chapters is it on? The homework? It's
the homework.
Yeah. It's chapters. It's section 4.4 and chapter 5. Another 4.4 was on Chebyshev and empirical rule and z-scores. And then the 5 would be that problem I'm telling you about, where I give you a data set. And
Okay.
Yeah. All right. So that's it. We're about 2 minutes behind. I think that you should. This quiz is not hard. You should be able to finish within the 20 minutes. But if you need more time, just send me a message at the end, and I'll extend the time for you. All right. So give me a thumbs up if you do see the quiz. Should be available right now. Yeah, you see it. So go ahead. Again, it should be easy. If you've been doing the work, I don't see how this would be a difficult quiz at all. It should be an easy quiz for you. So it's all vocab, no calculations. All right. So please, if you do have a workable video right now, please turn it on so I can see you. Good luck on the quiz, and I'll see you on Monday. And if you do finish the quiz early, you may leave early. Okay? All right, that's it for today. Turn the recording off.